Hello everyone. Today we are going to solve this question, longest divisor interval. So first we take the screenshot of the question and then put it on Excel draw. Then we solve this question. Like I take the screenshot and now I'm going to Excel draw and I'll just paste it on here. So the question is, we are given a positive integer and first we read the question and then analyze its time complexity. After that, we try to find optimal solution which can be accepted. Okay. So here we receive a positive integer and find the maximum sum of maximum size of an interval L and R of positive integer such that for every I in the interval, i.e. L to R, n is a multiple of I. So given two integer where L is less than R and the size of the interval L comma R is R minus L plus 1. So this is quite um, reasonable, like size to y of that. So it coincides with the number of integer belonging to the interval. First line of input contain total test case and the second line of input contain the an integer and we so in this question we receive an in, in- okay, and we have to find the total continuous continuous divisors. Ah, so for that, what we can do, I was first thinking कि पहले डिवीजन निकाल लेते हैं एंड देन फिर उसमें से कैलकुलेट कर लेते हैं कौन सा कंटिन्यूस बट दिस विल नॉट गोना हेल्प अस बिकॉज after analyzing the time complexity we see that t is from 1 to 10 raised to the power 4 and n is from 1 to 10 raised to the power 18 and what we are thinking that we first find the total divisors which could be like 10 raised to the power and in worst case so this will not gonna accept it because we have t is 10 raised to the power 4 and n is 10 raised to the power 18 like we want our solution should be run in 10 raised to the power maybe 4. So after getting this thought, what I try to do is I was thinking that I can calculate the what I can calculate. I can calculate the divisors continuously. Like in our first test case, we can see for one from starting I is equal to one. I one can be divisible by one. So 1 is our answer. If we go I plus plus, then 2 cannot able to divide 1. But, and same for 40. 1 can divide 40, 2 can divide 40, but 3 cannot. So our uh, I will go till 3, so we can return that I minus 1. Similarly for 990, at I is equal to 1, it will be divisible, and at I is equal to 2, it will also divisible. At I is equal to 3, it will divisible, but for I is equal to 4, it is not divisible. So we are returning here 3. Same for all the cases I analyze, and I come up with an intuitive solution. Like what we can do, we iterate through the starting I from I is equal to 1, and when we get a number which not divide or n, then we can return n minus I minus 1. Like build this solution. Mhm. Next, I include bits as stds plus enter using std main P for the first line input, and while t minus minus long end. Why we choose long end? Because our n can go up to 10 to the power 18. Then n pi is equal to 1, while कब तक जब तक हमारा divisible है. Divisible by I is equal to 0. What we can do, I plus plus, and when loop breaks, we return or I minus minus. This solution works fine, in my opinion. Like copy the test cases, paste it here. Like we get the solution for 140 to 3, 6, 4, 22, and 3, 1, 2, 2. You can check here. So we get the solution correct. Now choose the file, submit it. Down Divisor Interval, submit. Yeah, accepted. So this is quite a easy problem. That's it. Thank you for the day. Let's meet up on next day.